is even more radical. Now with the 1.0 version update of the double stick, you only need a minimum of 3 GB of VRAM to run it. So using the twin stick node and the corresponding 8-step model along with CN, you can generate an image in just 15 seconds. Remove CN and it becomes 11 seconds. If you use the 4-step model without considering the text, it becomes more aggressive. So it should take about 5 to 6 seconds to generate one image. The conclusion was based on tests using resolutions of 1280 by 720 and 1328 by 728, as well as machines with 24 gigabytes of GPU memory. Another update is the video extension technology updated by KJ. From the Buddha, we can add it to any segment of video to extend the footage. On the left side, you can see the last 24 frames that have stopped moving. And on the right side is an extension based on those final 24 frames. Then let's take a look at the workflow. I'm using the largest online ComfyUI platform, GitHub, which is the GitHub address for ComfyUI double pulse stick. On September 4th, there was an update to version 1.0, and finally we reached version 1.0. If we're using millions of pre-configured workflows, we just need to replace the corresponding parts where the large model is loaded. This uses into 4. The large model I'm using here is the 8-step version because the 8-step version best balances speed and quality. Its connection to CN is to see how our control performance fares after performing info quantization. The first one is depth testing, where during the process, the weights of CN are gradually increased. In the depth map control test, we can see that even under unique weight conditions, it can still express text. Moreover, after mixing various elements, the content presented in our scene becomes more interesting. In my opinion, $7,000-$10,000 per frame is still the biggest competitor to the Flux system. The second test is open pose. Here, we detected a sitting posture. Under sitting posture control, the higher the weight, the more accurate it matches our pose diagram. When all weights are equal, it has already achieved intelligence. The third test is inline control. Load an image and detect it with any line to generate an inline controlled image. When viewed from left to right, the inline constraints limit the expression of our text. Besides inputting text here, the final step is a basic test of a text-based image. A resolution of 1328 by 1328, generating a duration of 11 seconds. These 8 steps here differ from the tattoo design in that they modify one node and add CFG long. In the long Kempler, using CFG can help improve quality slightly in situations, like when using an acceleration model. The same applies to this test. Navigate to RunningHub, click AI or the link in the introduction to register, and you'll get 12 GPUs daily. Logging in each day also gives you 100 points. Corresponding AI workflows and one-click AI applications have been deployed online and can be run and tested directly. Let's look at the update on the video extension workflow. Although we've done many cycles of video extension, it still can't effectively combat issues like decay. However, in this case, we're just extending a single segment, so we only need to consider one shot without worrying about decay. On the left side, the input video ends with 24 frames, which is quickly processed. The extended video on the right is based on these 24 frames. Using KJ's flow, there's a serious issue. It creates a time reversal effect that says people walking backward or objects moving in reverse. Adding overlapping frames might reduce this problem. The advantage is that its extension quality is still acceptable. In just 24 or even 36 input frames, it can well capture consistency between objects or characters. If the desired extension isn't too complex, there's no problem at all. For example, the dynamic of a boxing scene remains intact. This workflow isn't universally applicable because it's specifically designed for the Buddha model. The documentation clearly states that using the Buddha model requires injecting special noise, hence there's an independent node for injecting special noise. As for updates, one video scheduler is very similar to the previously introduced MOE sampler. Both use a value of 12.875. Before the scheduler, we had to manually write signal values here for KT flows. With this scheduler, it's much simpler. Therefore, this node can seamlessly be inserted into previous shared workflows for completing videos and image-to-video generation. It's highly valuable. Regarding diffusion models, they correspond to ER models and some accelerated low-noise models. The large model used here is a tattoo video model. Actually, it's hard to understand why we previously did 3-stage video amplification using the same tattoo video model. Analyzing this video briefly reveals what it's trying to express. This video has 81 frames, indexed as -1, meaning it took the last 36 frames from the end and merged them with the input audio. Mathematically, it's a